Hello and welcome. Today we'll look at how to solve numerical problem that involves two-factor analysis of variance ANOVA with equal replication. The data here are plasma calcium concentrations in milligram per 100 ml of beds of both sexes, male and the female sex. Half of the beds of each sex being treated with no hormone and the other half treated with hormone. There's the hypothesis that there is no effect of hormone treatment on the mean plasma calcium concentration of beds, and also test that there is no difference in mean plasma concentrations between female and male beds. We also test that there is no interaction of sex and hormone treatment on the mean plasma calcium concentration of beds at 0.05 significance level. Looking at our table here, we have two factors. First factor being the hormone, that is no hormone treatment and hormone treatment. Therefore, the number of hormone groups which represent with small letter A is 2. Factor B, that is the sex, which will represent as B, is also 2 because we have the males and the females. Let N represent replicates per cell because each of the cells here contains 5 number of observations. That is 1, 2, 3, 4, 5. So our N value is 5. Let capital N represent total number of observations. That is A multiplied by B multiplied by small letter n. Of course, our A value is 2 multiplied by B multiplied by n, 5. Therefore, the total number of observations is 20. Now, let's calculate cell totals. That is the total for each of the cells. 14.5 plus 11 plus 10.8 plus 14.3 plus 10, 60.6. For female with no hormone, the cell total will be 16.5 plus 18.4 plus 12.7 plus 14 plus 12.8. 74.4. Now, the total for the male with hormone treatment will be 32 plus 23.8 plus 28.8 plus 25 plus 29.3. 138.9. Set total for females with hormone treatment will be 39.1 plus 26.2 plus 21.3 plus 35.8 plus 40.2. 162.6. Now let's get the grand total for the sum. That is by adding up all the sums. 60.6 plus 74.4 plus 138.9 plus 162.6 gives 436.5. Now let's create a column for the square of each of the cells. So we created a column for the square of each of the cells. 14.5 square, 210.25, 11.0 square, 10.8 square, 14.3 square, 10.0 square, 100. Now let's add all these values together. 210.5 plus dex plus dex plus dex plus dex, 752.38, 16.5 square, 18.4 square, 12.7 square, 14 square, lastly 12.8 square. Now let's add all these values together. 272.25 plus this value plus dex plus dex plus dex, 1131.94. Now let's get the square of these values. 32 square, 23.8 square, 28.8 square, 25 square, lastly 29.3 square. Let's add these values together. 1024.0 plus this value plus dex plus dex plus dex. Let's get the square of these values. 39.1 square, 26.2 square, 21.3 square, 35.8 square, lastly 40.2 square. Now let's add up these values. 1528.81 plus this value plus dex plus dex plus dex. Now let's get the sum of all the squares by adding up all these values. 752.38 plus dex plus dex plus dex, 11354.31. Now let's calculate correction factor CF. Correction factor is grand total square. Grand total value is dex divided by n, and our n value is 20. 436.5 square divided by 20, 9526.6125. Next, we'll calculate set sum of squares. Set sum of squares equals summation x. That is each of these values square divided by n. Our n value is 5 minus CF value. So we have 60.6 square plus 74.4 square plus 138.9 square plus 162.6 square divide by n. With this, our n value is 5, and then minus CF, and our CF value is this, gives 1461.3255. Now let's calculate cells degrees of freedom. Calculating cells degrees of freedom, we use this formula. Our A value is 2, multiplied by B, our B value is also 2, then minus 1. 2 times 2 is 4. 4 minus 1 is 3. Therefore, cells degrees of freedom equal 3. Let's fix this value into our ANOVA summary table. Take sum of squares. Let's also fix in cells degrees of freedom on our table. Cells degrees of freedom. Now let's calculate total sum of squares. Total sum of squares is equal to this value minus correction factor value, 1827.6975. Let's also record this on our table. Total sum of squares. Find total degrees of freedom. Total degrees of freedom will be capital N, which will got 20 minus 1, 19. Now let's record this on our summary table. Total degrees of freedom, 19. Calculate error sum of squares. Error sum of squares is equal to total sum of squares, that is this value, minus cells sum of squares, this value. So this minus this. Let's record this on our summary table. Error sum of squares. Calculate error degrees of freedom. Error degrees of freedom will be our A value is 2, multiplied by B, B value is also 2, and with this our M value is 5, minus 1. 2 multiplied by 2, 4. 5 minus 1, 4. 4 multiplied by 4, 16. Error degrees of freedom is 16. Let's also record this on our summary table. Error degrees of freedom, 16. Now let's calculate factor A sum of squares. That is, factor A comprises of no hormone treatment and hormone treatment. Therefore, factor A sum of squares will be total for no hormone treatment. For no hormone treatment, we have 60.6 plus 74.4, 135.0 square plus total for hormone treatment. For hormone treatment, we have 138.9 plus 162.6, 301.5, and then square, divide by 2 times n, and our n value is 5, minus correction factor value, 2 times 5, 10. Therefore, 135.0 square plus 301.5 square divide by 10 minus 9526.6125 gives 1386.1125. We'll record this value on our summary table, the A sum of squares. Now let's calculate factor A degrees of freedom. With this formula, A value is 2 minus 1 gives 1. Now let's calculate factor A mean of squares. Factor A mean of squares will be factor A sum of squares divide by factor A degrees of freedom. Now let's calculate factor B sum of squares. Factor B is sex, that is, we have male and female. Factor B sum of squares will be sum for males square and sum for males is 60.6 plus 138.9 gives 199.5, and then square plus sum for females, which is 74.4 plus 162.6 gives 237.0, then square, divide by 2 times n value is 5, minus correction factor value. Therefore, these values minus correction factor value gives 70.3125. Factor B sum of squares. Calculate factor B degrees of freedom. Factor B degrees of freedom is B, 2 minus 1, and 2 minus 1 is 1. Now let's record this on our summary table. Factor B degrees of freedom 1. Let's calculate factor B mean of squares. Factor B mean of squares will be factor B sum of squares, this value divide by factor B degrees of freedom, that is 1. Therefore, this value divide by 1. Calculate A and B interaction sum of squares. Interaction sum of squares will be cells sum of squares value minus factor A sum of squares value minus factor B sum of squares value, which is equal 4.9005. Now let's record this on a summary table. Interaction sum of squares. Now let's calculate A and B interactions degrees of freedom. So interactions degrees of freedom is factor A degrees of freedom, which is 1, times factor B degrees of freedom, 1 multiplied by 1. Therefore, interactions degrees of freedom is 1. Interaction degrees of freedom 1. Calculate interactions mean of squares. Interactions mean of squares is interaction sum of squares, this value, divide by interactions degrees of freedom. So this value divide by 1. Now let's calculate error mean of squares. Error mean of squares will be error sum of squares, this value, divide by error degrees of freedom, 16. 22.8982. Now let's test the null hypothesis, which states that there is no effect of hormone treatment on the mean plasma calcium concentration of births in the population sample. For the hormone being factor A, S value will be factor A mean of squares divided by error mean of squares equals 60.5. Calculated F for factor A being the hormone group is 60.5. Now we'll find our F tabulated by visiting ANOVA table, where we'll look at alpha at 0.05, that is the level of significance, and of course we are talking about one-tail test, and then degree of freedom of factor A being 1, 16 here represents error degrees of freedom. This F distribution table, one-tail test, and then our significance level at 0.05, and our degrees of freedom is 16 at this point. So the value is 4.49. So we'll call this F tab, that is the value from the table, while F cal, that is the calculated one. Making comparison between F cal and F tab, since F cal being 60.5 is greater than F tab, we reject null and conclude that there is effect of hormone treatment on the mean plasma calcium concentration of births in the population sampled. Let's also test the null hypothesis, which states that there is no difference in mean plasma calcium concentration between male and female births in the population sampled. Our F calculated for factor B, being sex, will be equal to sex mean of square divided by error mean of square value, which is equal to 3.07. Remember, our F tab gave us 4.49. Making comparison between F cal value being 3.07 and F tab value being 4.49. Obviously, F tab value is greater than F cal value. Therefore, here we do not reject null and conclude that the mean plasma calcium concentrations between male and female births in the population sampled. Now let's test the last hypothesis, which states that there is no interaction of sex and hormone treatment affecting the mean plasma calcium concentration of births in the population sampled. So F calculated for interaction will be interaction mean of squares divided by error mean of squares, which is equal to 0.214. Of course, our F tabulated value is 4.49. Making comparison between F cal and F tab, obviously here, F tab is greater than the F cal. We do not reject null and conclude that there is no interaction of sex and hormone treatment affecting the mean plasma calcium concentration of births in the population sampled. I hope this video is clear enough. Please, if you really got value, and at this point you are yet to like this video and subscribe to my channel, please kindly do that, as subscription is free. Also do it to share this video with anyone who might find it useful. Comment with any questions or topics you want us to cover in future video. Give this video a thumbs up. Thanks so much for watching. See you in our next video. Bye.